Alright, in this video I am going to show you how to do SIG number 12, which is graphical derivatives. What we're being asked here to do is find when the derivative is less than 0. This is when f is decreasing. Find when the derivative is greater than 0. This is when f is increasing. And find when the derivative is 0. This is when you get a maximum or a minimum, or sometimes you could have like a saddle point where it kind of just flattens out for a little while and then starts going back up. Alright, so we want to know at first when, and I'll do this, let's do this piece in red, let's do this piece in blue, and then this piece I'll just do in black. Alright, so when is our graph decreasing? That's going down, right? So well, here it's down, from there to there, that's down, and all up in this space it's also down, right? Well, when is it going up? When is it increasing? Like all of these values it's increasing, all of those values, I'm blowing this, is supposed to be in blue. When is it increasing? Let's go back to our blue. Increasing, all of these ones, all the way to there. And in this case, there's only one spot where it's 0, which is this black dot right there. So how do I describe that? All right, so I'm going to say, let's start with red since we did that. When is f decreasing? When is f decreasing? Sorry, when is f decreasing, or another way of saying that, when is the derivative less than 0, right? Well, the derivative is less than 0 starting at this black dot right here, which is an x value of 0, until 2, not including 2, because what happens at 2? Well, there's a vertical asymptote. So that, along with, starting at 2 again, but not including 2, all the way to infinity, my graph is decreasing, right? Even though it's really flat over here, it's still decreasing. All right, when f prime is increasing, let's go to blue now. When f is increasing, also known as this piece where f prime is greater than 0, is all the blue I marked on the graph. So it started at negative infinity, not including negative infinity, all the way up until -2, not including -2 because there's an asymptote. And then we combine that with starting at -2 again, not including -2, all the way up to that black dot, which is 0, not including 0. Because at 0, right, what happens at 0? F prime of x equals 0 when x equals 0 in this case, right? Right where that black dot is right there, there is a horizontal tangent, right? And there's a horizontal tangent right there, and my derivative is 0. So now I got to match this with one of these graphs down below, right? So what I know is from 0 to 2 and from 2 to infinity, my graph, the derivative graph, should be below the x-axis, right? So let's look at the first one. From 0 to 2 and 2 to infinity, is it below the x-axis? Yes. Right? All those guys are below the x-axis. Next one. Right here, it's not below the x-axis, so it can't be this one. This is all above the x-axis, can't be that one. And here, those are all above the x-axis, can't be that one. So just with that little bit of information, I could figure out the rest. Let's make sure this other part's good. You know, with x values of -8 all the way to 0, it should be above the x-axis, which is good. And then at 0, I should have a y value of 0, which is happening right there. So yes, this one is definitely good. The answer choice here is A. Let's go to the next part. This time we're given the graph of the derivative, right? We are given the derivative. We want to know when was f decreasing. So f was decreasing. Let's color code this, right? F is decreasing when f prime of x is less than 0, right? When it's below the x-axis. So I want to know, well, when is this below the x-axis? Well, it turns out it's below the x-axis here and here. And the only point that's a little bit weird is at -2 because there's an asymptote there. So we're going to say, well, f was decreasing from negative infinity to -2, not including 2, and then start again at -2 all the way to infinity. Turns out that it was always decreasing, right? So I'm looking for, in my graphs down here, a function that is always decreasing, right? Always decreasing, and something funky, horizontal tangent line, right? There's an asymptote here. So this should be, vertical tangent line. Vertical tan line at x equals -2. right? So, and it's always decreasing, always going down, right? Look at A. This is going up. This is increasing, right? There should not be any points where it increases. B is always decreasing, but nothing funky is happening at -2. So delete that one. Let's look at C. C is decreasing, always decreasing. A little bit of funkiness going at x equals -2. So this is maybe, right? And then this one, D. D here is increasing. I can't have any increasing, right? Because my derivative was always negative, so it can't be this one. So it's got to be C. If you notice, if you get really close to -2, you get a straight up and down tangent line, which is vertical, right? So the answer there is C. All right. Hope this is helpful. Come ask questions if you're still confused.